All right. So let's say you're down at your local diner and somebody throws you this polynomial and says, I want you to factor that baby. Or find all of its roots. Okay, that's probably not going to happen. And if it does, somebody will probably beat you up and kick you out. But anyway, here alone in the school, I can do this. So 2x to the fourth plus x cubed plus 39x squared plus 136x minus 78. The first thing I would do to figure out the roots of this thing, or the zeros of this thing, is to go in and use the rational root theorem. So there's lots of possibilities here. You could have plus or minus 1/2. There we go. Plus or minus, and I'm just going to fly through them quickly. Plus or minus 1, plus or minus, plus or minus 1, plus or minus 3 over 2, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 13 halves, plus or minus 13, plus or minus 26, plus or minus 39 halves, plus or minus 78. So those are all possible rational roots for that equation. And we know by the fundamental theorem of algebra that the highest degree is 4, so there are 4 roots here. Now, there could be 4 from the list that I just gave you using the rational root theorem. So what we're going to do is I'm going to limit this list a long ways down and graph it. So when I graph this thing, I'll try not to get too loud, hopefully. When I graph this thing, I use GeoGebra because that's just the quickest one. When I graph it, there's what the graph looks like. And if you notice, it looks like -3 is a root. And we can go ahead and intersect where it crosses the x-axis. Looks like -3 and 0.5. And we're going to verify that here in just a second. But those look like our 2 rational roots. So, oops, there we go. So essentially we are going to divide this whole function. So, bear with me for a second. So, I'm not going to rewrite h at x again, but we are essentially going to divide it by x plus 3, and then we're going to go ahead and divide it, h of x, or this thing, then, by x minus 1/2. So we're going to divide it twice. First by x plus 3, and then second by x minus 1/2. Because basically we know we have a polynomial just by that graph of it's x minus 3, h of x is going to be x minus 3 times x, or x plus 3, sorry, times x minus 1/2, I knew I had screwed up them signs, times a whole bunch of other, so another second degree polynomial, x squared. And the little squiggle here means we're going to fill that in with something. We're going to find out what that squiggle is here shortly. So I use synthetic division. So we're going to go -3 in the box. This is our first task, is divide by x plus 3. So we're going to divide by the -3 root there. And you'd have 2, 1, 39, 136, and -78. And hopefully I didn't make any sign errors. I didn't, I don't think so anyway. Bring down your first term. Again, if you don't know what synthetic division is, you need to go look up synthetic division online or go look at one of my other videos. So that would be -6. 1 minus 6 is -5. That would be 15. 15 and 39, we got a 4 there. 3, 4, 54 there. 54 times 3. Okay, I paused for a second just to make sure I didn't screw anything up. So 54, and then 54 times negative 3, let's see, no, negative 120, no, 162, negative. And then 136 minus 162 is negative 26. Then negative 26 times negative 3 is positive 78, and we get 0. Now, if we didn't get 0, that's bad. That means we made a mistake somewhere. Either our root is wrong, we get a sign error. You got to go back and see what else is going on. So now we've got this new function, which is 2x to the third minus 5x squared plus 54x minus 26. And now we're going to divide that by the next rational root, which was x minus 1/2. So just kind of showing you what's happening. So we've got this result of 2x to the third minus 5x. We're going to divide it again. So you take the negative 1/2, divide it again. I'm going to bring down my terms. So 2, negative 5, 54, negative 26. Bring down your first term. So that's 2. 2 times negative 1/2 is 1. That'd be negative 4. Negative 4 times negative 1/2 is positive. Nope. Oh, I got a mistake. See? I was screwing up. Oh my Lord. Bad, bad. That's what's going to happen to you. I actually caught mine early. I would have got to the end and not gotten 0. Then I'd had to backtrack. But I want to show you what could happen. Again, and I didn't mean to do it, but I wish I could say I did. Most teachers will say, yeah, I meant to do that. But I didn't. I screwed it up. X minus 1/2, you set that to 0, so that means our root is positive 1/2. Whew, bad news there. So, starting back over. So 2 times 1/2 is 1. Negative 5 plus 1 is negative 4. Okay, that's looking better. Negative 4 times 1/2 is negative 2. 54 minus 2 is 52. 52 times 1/2 is positive 26. And that is 0. Thank goodness. Whew. So we have a new root, or a new polynomial. So we have 2x squared minus 4x, a little bit of lag, plus 52 equals, now, well, obviously, you know, I'm not setting them equal to 0 because of this. That my remainder is 0. So that's my new polynomial. Divided out evenly. It was x minus 1/2 was a factor of that. Now, it's a quadratic. So to find the answer now, we're going to use, it either factors or use the quadratic formula. At this point, most all of these are not going to factor, you know, if you're here in your education. So we're going to use the quadratic formula most of the time. So, or I shouldn't say they're not going to factor into a rational number. They're going to factor, and I'm going to show you the factors, but they're not going to factor rationally. They're going to be irrational or complex roots. So here we go. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. And if you want to watch me singing that online, just look it up. Shaban singing the quadratic equation. You can sing that to Pop Goes the Weasel and learn it. But anyway, x equals 4 plus or minus the square root of, you know, negative becomes a positive. I should probably show my work. There we go. Negative 4 squared. Now I'm going to feel a little bit better about it. Times 2 times 52. And then you divide that all by 2 times 2, because A is 2. You know, A was 2. I should have done this to start with 2. B is negative 4, and C is 52. I jump into, oh my gosh, not 54. I jump into these quite a bit without doing that first, and I've noticed that loses people, so I apologize. But A is always your in the quadratic formula. Here's my formula. A is 2, B is the negative 4, and C is the 52. And so now we're just going to keep on simplifying. And so negative 4, so that'd be x equals 4, plus or minus the square root of 16 minus 416, if you multiply that out, all divided by 4. And so you keep going, you got 4 plus or minus the square root of 400, all over 4. And the square root of 400, and is it, oh, and it's negative. Ooh, almost made another sign error. That's why you always want to double check. So x equals 4 plus or minus, it's going to be imaginary. Square root of 400 is 20, and the negative is the I, all divided by 4. And then that simplifies, you can take a 4 out, and you'd have 1 plus or minus 5i. So we have two roots here. X could be 1 plus 5i, and x could be 1 minus 5i. And so we've got, finally, I don't know what I called this. Did I call it h at x or something like that? Yep, h at x. We finally found out what it factors into. So h at x equals x plus 3, x minus 1/2, x plus, ooh, oh, dang it. There we go. So x, well, we can do it this way. X minus 1, dang it. That's going to screw it up. X plus, no, it is minus. Yeah. X minus 1 plus 5i. Yeah, that's right. And x minus 1 minus 5i. Lots of parentheses there. And it's hard to, you probably never factored something into imaginary factors, but that is essentially what's happening there. And the reason I was kind of struggling right here, because I'm like, it should be a minus. Oh, it's a plus. No, it's a minus. It's a minus, because if we were to set that to 0, x minus 1 plus 5i equals 0, you would add all of this over, and that would give you your answer, or your root. So it's always x minus the number, because you always switch your signs. That gets everybody in trouble. X minus 1/2 equals 0. Well, my root is positive 1/2, because we're looking for the zeros. So even when you've done this for 20 years, you have to think about it a little bit. So best of luck. I hope this helps. Those are my 4 roots. If you were crazy and wanted to multiply those all back together, when you're done multiplying, it'll take you some time, but you'd be left with 2x to the 4th plus x to the 3rd plus 39x squared plus 136x minus 78. That'd be so cool if you got the right answer. It wouldn't be cool if you multiplied that all out and you had a sign error somewhere. But anyway, have a good rest of your day, and see you next time.